Okay, so just some examples to do with calculus and mechanics. So first of all, we are given that v is equal to 6 root t, or 6t to the power a half. And they're asking us to find the displacement and the velocity and the acceleration when t is 1. Well, first of all, we can see that when t is equal to 1, the velocity is going to be 6 times the square root of 1. Take the positive square root, so in other words, the velocity is going to be 6 meters per second. We can find that straight away. Now the acceleration, to find that, the acceleration is dv by dt. And in order to differentiate that, so we do half times 6, which is 3t to the minus a half, which is the same as 3 over the square root of t. So that means that when t is equal to 1, the acceleration is going to be 3 over the square root of 1, which is 3 over 1. So the acceleration is going to be 3 meters per second. Now, to find the displacement, we need to find the integral of the velocity with respect to time. So we want to find the integral of 6t to the power a half with respect to t. So integrating that, we get t to the 3 over 2, and then we're going to do 2/3 times 6, which comes out as 4. Don't forget, though, there's that constant of integration. So s is equal to 4 t to the 3 over 2 plus c. Now we're told that the displacement is 30. So 30 is equal to 4, and then that's, what is it? Displacement is 30 when t is 4, so 4 times 4 to the 3 over 2 plus c. So 30 is equal to 4 times, or 4 to the 3 over 2, that's the square root of 4, 2 cubed, which is 8, plus c, which gives us that 30 is 32 plus c, so c is going to be minus 2, which means that our expression then for s is equal to 4t to the 3 over 2 minus 2. So the question says, what is the displacement when t is 1? That means that s is going to be 4 times 1 to the 3 over 2. Well, that's just 1 minus 2, so that's 4 take away 2, which is 2 meters. So the displacement there would be 2 meters. Okay, another example here. We're told that a is equal to 2 minus 6t to the power minus 3. So the first thing we need to find, well, we can find the acceleration when t is 3. So the acceleration is just going to be 2 minus 6 over 3 cubed. So that's 2 minus 6 over 27, which is 2 take away, if we divide the top and the bottom by 3, that's 2 minus 2 ninths. So in other words, that's going to be 1 and 7/9 meters per second. Right, the next thing we need to find is the velocity, and the velocity is going to be the integral of the acceleration with respect to time. So the integral of 2 minus 6t to the minus 3 dt, and that's going to give us 2t, and then that's t to the minus 2. So in other words, it's going to be plus 3t to the minus 2 plus c. Now we're told that the velocity is 6 when t is 1. So we know that v is 2t plus 3 over t squared plus c. The velocity is 6 when t is 1. So v is equal to 2 plus 3 over 1 squared, or that's just 1 plus c. And that's going to give us that c is 6 take away 5, which is 1. So the velocity then is 2t plus 3 over t squared plus 1. So if we want the velocity when t is 3, that's going to be 2 times 3 plus 3 over 3 squared plus 1. Well, that's 6 plus 3/9, well, that's a third, plus 1. So that's 7 1/3 meters per second. Okay, now we need to find the displacement, and the displacement is going to be the integral of velocity with respect to time. Now we know that the velocity is just this, so it's 2t plus 3t to the minus 2 plus 1. So that's the velocity, so I'm going to integrate velocity with respect to time. So that's going to become t squared. T to the minus 2 becomes t to the minus 1, so that's minus 3, and then plus t. I'll put a different constant, so let's call it k. And we are told that the displacement is 0 when t is 1. So 0 is going to equal 1 minus 3 over 1 plus 1 plus k. So 0 is going to be, well, that's 2 take away 3, well, that's minus 1 plus k, so k is going to be 1. So our expression for the displacement, s is equal to t squared minus 3 over t plus 1. So if we want the displacement, what did the question say? The displacement when t is 3, so s is going to be 3 squared minus 3 over 3 plus 3 plus 1. Well, that's 9 minus 1 plus 3 plus 1. In other words, the displacement is 12 meters when t is 3.